more chat about that. All right. Hey folks, thanks for joining us. For those of you who are joining on Zoom, and also for those of you who are joining on YouTube, we have a couple minutes to go. Hey Phil, hey everybody. Yeah, let us know in the chat where you're all from, as per usual. And a reminder for those on Zoom, if you're not sick of hearing me say this yet, to change that little bar in the chat from all panelists to all panelists and attendees if you'd like to talk to everybody. I also did set up a poll because today's topic is double stars, and this is a controversial topic for John and I.
I don't think it's actually controversial. It's just
not controversial. John just really hates double stars. Blake Nancarrow is here, so you can't say anything mean about them because Blake knows everything about double stars. So I think double stars are great. John does not like them. So I've created a poll once again because I basically all I do is use you all to settle arguments between John and I. So I've just launched the poll about whether or not you've seen a double star and whether or not you found it hard to identify correctly, because that is one of John's primary complaints.
So no. So to clarify, I love double stars, especially from a scientific standpoint, because double stars are how we learn a lot about stellar composition. So like if you have double stars, if you can orbit something, you can weigh it. So from an astrophysics standpoint, that's really important. And if you can weigh it, or if they're eclipsing binaries, then you can get their radius, which if you can get radius and mass, you get density. So that's really helpful. And then there's spectroscopic advantages, which means as with eclipsing binaries, you can analyze the light of each star independently. So there's a ton you can learn from a scientific standpoint about binary stars. So that is fantastic. And then from an observational standpoint, stop me if you want me to end rant. Anyway.
you can share your opinion.
Yeah, my opinion. From an observational standpoint, there are some beautiful double stars. My favorite is Winter Albireo, or Canis Major 145. And so this is right off the sort of the backside of the Greater Dog, in the winter. And beautiful double star. You've got a bright blue giant and a sort of a orange gold giant. And then Albireo, which is the one that you would view tonight, with a telescope. You've got a blue giant and sort of a yellow giant star, and the contrast between the two colors of those stars and how easy it is to find. It just makes it, really fun. That said, if you're going and just hopping from double star to double star, because almost, a very large percentage of the stars in the sky have companions. And if your goal is to just see all the double stars that you can, or like sort of check them off your list, I find personally it gets a little bit redundant, because a lot of stars, if they're just the same color, I'm like, okay, so what? There's two stars that are side by side. All
right, okay, fair enough.
So that's my thought on it.
I'm gonna end the poll so you guys can see. So a lot of folks have seen double stars before, which is awesome. And that they had some difficulty identifying them, which is actually why we put it all in one, we put as many of them in one session as we really could, was because we wanted to go into more depth about how to see them well, because I too have some difficulty figuring out which ones are the ones that you're supposed to be looking at. Sorry, I forgot to share the results. There you go. Just because I find, especially using a telescope, I'm still not used to how the view flips. And so then I look at it and I'm like, it doesn't look anything like, and are those two stars close enough to be count as double stars, or are they not? And so I found it a bit confusing. So that's why we put everything together in this one session. I do want to say in advance that we already did a session with Insider's Guide to the Galaxy, which is a different video series that we run, and that one's with Chris Vaughn, who is a Toronto Centre member. And we also had Blake Nancarrow, who is in the chat and knows everything about double stars. He was our guest for that show, and so the link is in the chat, and I'll throw it up on the YouTube chat as well. Oh wait, I'm not logged into my work account. Yeah, so if you guys want to learn more about double stars, not just how to find them, but what they are, that video chat is, that video is a really good one to watch. So that Blake goes over a ton of different stuff. We're going to kind of cover some basics there as well, but that one goes into great detail. So first, John, you want to talk a little bit about news and things before we get into our targets for this week, huh?
Yeah, so just what have you been up to? Have you been observing? Did you get last week's targets?
Nope, it's been cloudy every single night. It's so sad.
No way.
The only time it wasn't cloudy was last night. And so I mean, the moon was pretty much full. So I didn't get to see
Yeah,
anything of the targets that we had last week, but yeah, it's been really cloudy. I did see the wild duck cluster, which I was very excited about. What about you?
cool. Yeah, so I saw them, but I don't think I technically get to check them off because I had the camera connected to the telescope, so I was photographing
Count.
the objects as opposed. So it doesn't. That's
It
that's
doesn't
a
count.
no
So no,
in
no.
terms
You
of
didn't
being
see
able
it.
to check
Only
them
the
off.
camera saw.
Beautiful, beautiful pictures though.
That's good.
Um,
And for those of you, yeah, clouds, Marie-Claude mentioned that it was just clouds and more clouds. Let us know if you got to see anything from last week. And the thing is, we do still have a couple more weeks of summer. And the way that the earth happens to, or rather the sky appears to move around us, we get a long time with this season. So you get a lot of chances to, you get a lot of chances to see it. Katrina just asked, why doesn't it count? Is that a can of worms? I don't know the specifics. All I know is that the observing committee does not count assisted viewing, essentially, so electronic viewing.
yeah,
But they are aware of the issue, and in terms of not counting it, in that it's much more accessible if you do count it. So like people who can't see very well or people who don't have good dark adaptation may need that electronic help. So I think it's on their radar of things to consider for the future.
yeah. It'd be neat if there was almost like an Explore the Universe accessibility version.
Yeah, and I think that Blake just mentioned that we've formed a working group on it. So thanks, Blake, for being up on the news.
And I'd love to be on
Awesome.
that committee too. That sounds like it'd be a lot of
Yeah, it
fun
sounds
and
cool.
something that I could help contribute to as well. So I guess in news that we haven't talked about, so despite COVID, they're letting me keep my job at the observatory at St. Mary's. And so what they're doing is they're moving it all virtually. So Dave Lane, who's the director of the observatory, has developed some software so that we can easily, because you could do it before, but now it's going to be easy, control the different telescope sites live from home. So there's a custom app that will enable, and so it looks like half the screen is what the telescope sees, and then the other half of the screen is like, controlling it left, right, up, down, and then go to targets. So it'll be really interesting, and we'll see if he lets me use that outside the context of being a teaching assistant for the foundations and astrophysics courses. But that'll be really neat if we can bring that level of accessibility to the public as well. So I guess that's a little piece of news that I'm really excited about. I can't wait to dive in and start using these telescopes, and it's more than one. So it's like a small 4-inch telescope out in dark skies, a 16-inch telescope in dark skies, and then the 26-inch telescope on the roof at St. Mary's in light polluted skies. So that's going to be a lot of fun. And so keep following me at Learn to Stargaze, and hopefully there'll be some events that are outside of the context of the university, and we can all join in and do some super duper live stargazing with some big scopes.
That'd be very cool.
Yeah.
We should, Aina, remind me to talk to you about that in terms of the Mars opposition. We'll be in touch. Not live. And Lisa Ann asked that, don't you have to find the object before you photograph it when we're talking about photography? And yes, that's true, but I don't know if it's usually with photography rigs, they're almost guaranteed they have to be computerized or motorized, because otherwise you can't take pictures for a long time of the sky. So it's much easier to just go, I want to see this thing, and the scope finds it for you before you photograph it. So
yeah, I didn't even use a finder scope, so I can't even count like looking through it through a finder scope to find it.
True.
I never even brought an eyepiece out of the garage.
Oh wow.
So
there you go.
the camera was attached the entire time. So
yeah, you don't count. None of that counts.
I think had I looked, on one of the nights I used a Dobsonian, had I looked through the finder, which is a telescope, then it would have counted.
Maybe, there you go.
Yeah.
Loophole. Okay, let's talk about our targets. I do have some like general science journalism stuff to mention. So if we have time at the end, I'll mention it. But for now, I want to get through the targets that we have and talk a little bit about double stars and stuff like that. First off, though, I am going to start with the targets that are not all double stars, the ones that have specific days attached to them, because we have 3 of those plus the waxing phase, which I forgot to write down for this week. Let me grab Stellarium. We have a big front coming through right now, so we have really high winds and storms, and I'm a little worried about the hydro here. So I'm hoping that it doesn't go out.
Because you were in northern Ontario, right?
I am, and I saw that someone's coming to Manitoulin, and that's where I am at the moment. So we have some fantastic dark skies, and they're going to go to Gordon's Park probably, which is a RASC designated dark sky preserve, and is run by lovely people. It's a neat place to go. It's a long way north of the city, but they've got really nice camping, and they've got astronomy nights and stuff like that. So it's a lot of fun. Okay, so for tonight, if you have clear skies, we sure don't, but if you have clear skies, we have a lunar crater that we can see tonight. And that is Petavius. I find this one a little difficult, so I also did grab a picture of it as well. This one's actually technically, you would be normally viewing it in the very first days of the moon, so like the lunar day 2 or 3. And we actually had someone mention this to John as well. This is a lunar day 2 or 3 crater, but every lunar crater has an equal other day when the moon is waning, where you can see it. And the reason that I chose a waning phase for these 2 is that they're so close to like the beginning of the lunar cycle that when you do get that 2 or 3 day old moon, you only have like an hour to catch them, and you have to have a good view close to the horizon. So in this case, because it's lunar day 2/3, tonight and tomorrow, lunar day 14 plus 2 and 3, so 16 and 17, today and tomorrow, you should be able to see them like almost the entire night. The moon rises, and you got this here at like 9:30. So you don't have to stay up super late to see it like you would in June, for example. You get lots more time during the night to see it. So that's why I chose this, and it may not work for you. And if it doesn't work for you, give it a shot on the next lunar cycle when it's day 2 or 3. I've never really tried to observe craters on the gibbous phase because I am not a functional insomniac, and I do go to bed at like 9:30 at night.
On the waning phases.
On the waning. Did I say waxing?
That's me too. So even if you're following along in 50 Things to See on the Moon, that book only covers the waxing phases. So these targets, which are sort of, I guess, on the east side of the moon, they are, primarily ones that you get on day 2 and 3. But and then even in the book, I didn't mention again that they're sort of on the Terminator again, late at night.
The other way around.
The full moon, yeah.
Yeah. So you can see them both times. It's just that they will look a little different, and the objects you use to like properly identify them will be trickier as well. All right. Yes, and Katrina, yeah, you can see it getting dark here. Right? It's like super dark right now, even though it's only 3:30 in the afternoon. So here is the moon tonight, and all the craters that you're looking for are going to be right along the Terminator. So you may actually have to wait until tomorrow night to see all of them. You might be able to see some of them just a little bit fainter tonight, especially if you have a telescope. They'll be good tonight, but for binoculars, you may have to wait until tomorrow night or later in the evening. So we have 2 craters. One is Petavius and one is Cleomedes. Petavius, I've never seen because it's got 3 other craters around it, and I find that very hard. So yeah. Petavius is.
I find these ones easier on day 2, 2.5, because these are what Dave Chapman calls the gang of 4. So if it's early in the lunar cycle, these are really almost the only craters that you can see.
Yeah.
And then if you've got a telescope, Petavius is doubly interesting because it's got these walls inside of the crater that almost look like clock hands. So if you've got high magnification, I call this, at least in the book as well, it's called the clock hand crater. Just because of these walls that sort of stretch out inside the crater itself. Cool. So again, we're at whatever it is, day 16?
16 today, so.
Yeah, because now you've got, hundreds of craters that are visible, and so you've got to pick it out of that, massive crater. So that's where, it gets slightly more challenging. But
so maybe I have led you all astray.
So if you're not using an inverted version, it's the second big crater of the 4. So there's 4 big craters in a row along the Terminator. It's second from the bottom.
Yeah. So this one is from that website that I showed you guys a couple weeks ago. Derek Scope, is that right, John?
I guess I just call it Derek Scope. Yeah.
Yeah, Derek Scope. It was a website from the UK where the person has a bunch of photos of the lunar cycle almost every day. Except for some reason they're all upside down. So I flipped this the right way up and have also pointed out the craters that are the ones that were like, you'll be able to see. So there are 4 in a row. We have Furnarius from the bottom, then Petavius, then Vendelinus, and then Langrenus. Langrenus, I think, is probably the most prominent one. But Petavius is the one that we're looking for in that group of 4. And then Cleomedes is the first one above Mare Crisium in any scenario, whether like there's no other crater that you could mistake it for. So Cleomedes I find is a little bit easier. And then Petavius is like the 4th one in this big row. So give it a try tonight, tomorrow. And if it doesn't work, we'll go over it again. Are we going to hit the first lunar day? It may that like lunar day 2 or 3 might be the day that we have our next session. So we'll give that a try because usually it's 14 days apart. So it should be about that.
Yeah.
So we can always go over it again then. I also wanted to, did I want to mention? Oh, the other thing that's happening, this is exciting as well. Back to looking at Stellarium, is on the 5th, which is Saturday night, on the 5th, we have I'm going to scoot us back in time and go back to the moon.
Oh,
we have
a conjunction.
Yeah, we have a conjunction. So if you haven't seen a conjunction yet, this is a good one to see. We have Mars and the moon conjuncting, and I have this so bright that you can't really tell. There they are.
This is the one that scam email was going around about.
There's a scam email about this one? There's a scam email about astronomy?
Yeah, so the scam is, and I guess they use it, I feel like it's this Russian ploy where they want to like sort people by who's gullible. And so what they do is they mass send out emails with, and it's this email where it shows the moon and Mars at the same size.
Oh.
And it goes out all the time, and then astrophysicists get inundated with emails like, is this true? What's going to happen? What does it mean? And it's like, no, it's not true. Mars as big as the moon is the big, and it's just like, that's not what,
that's not what happens. Mars is never going to be as big as the moon. And if it is, then we have some serious problems. I do like that this is your theory is that it's Russian hackers. And if you'd like, I can make you a toque with a tinfoil liner so that no one can see.
Exactly. Yeah. But yeah, so if you look at one of the smallest craters on that previous picture, or like if you were to zoom in, Mars is only going to be as big as one of the smallest craters that you can see. Right. So
like one like that big sort of thing, maybe.
Maybe that. Zoom in.
Because I have Mars set so that it's really bright, so it's not really the accurate. There's Mars.
Yeah. Your Mars is like inflated with.
Well, I want people to be able to see it, but you can. Yeah, so it's pretty darn small compared to. Can we get the moon and Mars in without it getting really bright? Yeah, there you go. So it's pretty darn small compared to the moon.
Yeah, really small.
Yeah.
And sometimes they occult each other, and that means that one goes behind the other. And so when they did that in February this year, I actually got a picture of it. And so I have a picture of, and it was using really high magnification. I actually did it only with this telescope.
Nice.
And you could see Mars setting, but you're zoomed in so far that the moon looks flat almost.
Oh, that's cool.
And then Mars, went behind it, and it was during the day. I caught it on video.
Oh, good for you. That's tricky.
Yeah.
So this is not an occultation where the moon goes in front of Mars. This is just a conjunction where they get close together.
Yeah.
But they are going to be really close together. This is half a degree away from each other at the closest. So yeah, a degree is 60. What is that? Arc seconds? Arc minutes?
Yeah. 60 minutes. Yeah, 60. So in binoculars, this will be in the same field of view. And if you're using a telescope like, a beginner telescope like this, it's definitely, you'll get both in the same field.
Yeah. So
which
hold
is kind of cool because, if you have a small telescope like this, and you're looking at the moon and Mars in conjunction, what time of day is this? It's like at midnight?
This is right after sunset. You can see it it rises at 9:30 or so. Yeah, just after 9:30. And then they get closest to around 11:30.
Okay. Yeah. So if you're out there and you put your iPhone and try and take a picture, you'll be able to get the moon and Mars in an iPhone photo without too much messing around.
Yeah. And And this is so the circular ring here is the binocular field of view. So they'll be really close together. If you're feeling fancy, you can try to hold your phone up to your binoculars as well to try to take a photo, but that takes a lot of coordination.
That takes some mad skill right there.
It takes mad skill, but if you do it, we will award you some sort of imaginary award.
Well, you'll get rewarded with lots of likes on Facebook and Twitter.
Oh yes, it's that validation from the internet that you would get rewarded by. Yeah, so that's exciting. That one's on September 5th, and because the targets this week are all they're all double stars, you can actually go out and see them all at the same time as the Mars and Moon conjunction if you want to. The stars are relatively bright that we're looking for, so the moon won't affect it too much. So that is an option if you want to. You can do all your observing on Saturday night.
Yep.
Okay, those are the only time-sensitive things. Everything else is, all the other objects that we're looking for this week are visible for large swaths of time because they are stars. Mm. Okay, before we jump into them, I'm actually gonna stop sharing that for a minute. I do want to talk about some tips for observing double stars and some general information about double stars as well. And I have a list of all these things. First of all, yes, sorry, John, you can jump in anytime.
I'll jump in.
Please do, with anger. I have no doubt.
I learned a lot about observing double stars because I was trying to, when I wrote the books, it was really important for me to have observed everything, and then photograph everything. And some of the double stars, it was really challenging for me to do. And I wasn't quite sure why. And I wasn't quite sure what I was doing wrong in terms of viewing these double stars. And it wasn't until my 4th year of an astrophysics degree that I learned some of the science of why using the big telescope that I was using might not have been the best option. And that was really neat.
Right. Interesting.
Yeah. So we'll go into that in a minute.
Yes, we will. First off, I wanted to mention that while we have had targets that are not good city targets before, these are all really good city targets because if you look at, let's say, the brightness of a galaxy, it might be, or a globular cluster, it might be, magnitude 5, but it's spread over a giant area. These stars are magnitude 5 in tiny little points of light. So they cut through the light pollution a lot of the time, which makes them pretty easy to see in the city. So these are the reasons, basically, these are the reasons that I like double stars, is that you can see them anywhere. You can also, a lot of astronomers call them the sky's jewelry box because they are so many different colors. That I appreciate for other people. I am very bad at seeing color. So every time people are like, that's a faint lilac color, which I read is one way that someone described one of our double stars today. I'm like, haha, okay, it's white. But some people see color better than I do, and they are fun for that reason, to be able to pick out those different colors. I heard that, and I've never tried this before, but I've heard that if you want to see the color of the star, it helps to defocus your binoculars or your telescopes, that the light is spread out over more area and you can see it like more of a color in that space. Have you tried that, John?
Yeah, I've tried that with mixed results. Yeah, I remember some of the color has to do with how high the star is in the sky and what is going on in the atmosphere at the time. So if your star is sort of low in the sky, it will look red. And if you're in a place like Toronto where there's a lot of pollution, the stars will err towards red, just because there's so much dust in the sky. So there's that to consider as well.
Okay, good to know. And also I that brings up an interesting topic as well. I've had a couple questions like, why are there no green stars or purple stars? And I thought I would address that as well. So I have a bunch of scientific diagrams, everybody's favorite thing, to show you what
this is such a fun one. I'm so tempted to I wish I had a whiteboard.
Here's my whiteboard for today. Here is a diagram that shows it.
It's overly complicated for this.
It is, but I have an explanation. Let me explain. Okay, so stars are what we would call black bodies. They're whatever. They let's say they emit light. That's all that really matters for us right now. And they emit all types of light. This is a diagram that shows all types of light, but it also shows in this line the light that the stars emit based on temperature. So you can see what color the stars are. Oh no, you can see what color the stars are based on where the line goes through. So you'll see that it doesn't go through the green section and it doesn't go through the purple section. And that's because stars that would maybe, let's say, so all stars have a peak of light that they emit at a different color. And a star that would maybe peak at the color green also emits a ton of red and blue light. And so that balances it all out and we see it as white. Whereas a star that peaks at blue doesn't necessarily release, sorry, about my hover zoom, it doesn't necessarily release a lot of red light. So then we do see it as blue. And same with a red star doesn't release a lot of blue light. So we see it as red. The reason we never see purple stars is because so all stars eventually get, in terms of their temperature, as they get hotter and hotter, they get closer and closer to blue. And the reason for that is because no matter how hot you get, stars will always emit light in the visible spectrum. So you will never have just and purple is just outside of like we have violet right at the edge of the visible spectrum, right down here. And then ultraviolet. You will never have a star that just releases ultraviolet light. There's always some other color of light and of visible light in there too. So if it's releasing other visible light, it'll average out more to blue than it would ever to violet. Is that an accurate?
That's a great explanation. Yeah.
Thanks, John. I only figured out all the details to that because I've had it explained to me before, and I've been like, okay, I understand about a third of that. But I finally sort of like grasped it by reading about a million Wikipedia articles today. So I feel very excited about that. And this was another diagram to show the different types of star. And essentially that as stars get bigger and hotter, they just end up being more and more and more blue.
Yeah.
They just emit more light overall.
So that's the mere reverse of the way they usually do it. That's a funny diagram.
Yeah, I know, it's backwards, eh?
Yeah, because so these are the types of stars, O, B, A, F, G, M, K. But usually the acronym is like, oh, be a fine gal, kiss me, which they're trying to replace that
with something that's not,
not involves kissing and whatever.
Yeah.
But yeah. So usually you start on the left with your blue and then you go anyway.
Mm-hmm. Well, maybe they'll try making an acronym in the other direction now.
No, actually that is brilliant right there. Because we've been trying so hard to, of course then you have to flip the whole HR diagram.
It's worth the effort.
Maybe.
Okay, so that's why we don't have green and purple stars. Although I do like all of these different names. An echo of cerulean reminiscent of an ocean on a summer's day. Thank you for that, Katrina. You do have to, so I was looking at some of the stars that we have today, and one person did describe two stars as a pale yellow and a faint lilac, and I just was like they're both white. That's what, sure, let's make it poetry. Yeah, so that's the difference between or why we don't have purple and green stars. And now, John, do you have anything else to add, or shall we go? Oh, the other thing, I was going to give you guys tips on how to properly see them.
So you go first, then I'll add in sort of my experience.
Okay, my only tip is use binoculars. I have two tips. Use binoculars because they're your normal vision. So if you've looked it up in Stellarium, it'll look most like what you've seen in Stellarium. And the other option is also draw what you've seen in Stellarium. Decide where you're going to go and observe it. And so then you have something to reference when you go out and look at it. Because otherwise, I find that I'll go out, and if I look, especially if I look with a telescope, there'll be a giant mess of stars, and I'm like, I don't know which of these is the one I'm supposed to be drawing. And so with binoculars, things end up a little bit tighter together, and they're a little bit, easier to identify which one's the actual proper double star. And binoculars are the view that you expect it to be, whereas the telescope will either flip it sideways or upside down or whatever, which I find just makes it extra hard.
Yeah. Now so with binoculars, you're only going to be able to see the double stars that are of a separation that allows you to do that. So I haven't gone through this list thoroughly, because I exclusively look at double stars through telescopes. So I sort of have the opposite perspective on this. And when I look at double stars, I make sure that the telescope is centered exactly where it's supposed to be before I move and look into the eyepiece. So I already know that it's centered on the target before, so there's no hunting involved. Mm-hmm. That's just how I've done it. Now, if
it's just there,
I guess it depends on experience or trial and error as well. If you're using binoculars, that means that you're searching for double stars that have a separation that you can see with only 7x or 10x magnification. Mm-hmm. A lot of the time you might need 100 times magnification to be able to actually split that star into two stars, in which case you're bound to be using the telescope.
Yeah, the key is with this program, it's developed for binoculars. So you should be good with binoculars on all these targets,
Yeah.
which makes it simpler. And so for the sake of this program, I would say just if you have binoculars, use binoculars because it's like you're not looking for super, super, super tight double stars in this case.
Yeah. And Dave Chapman clarifies that all of these ETU doubles are viewable in binoculars.
Thank you, Dave Chapman.
Thank you, Dave.
This,
Yeah, I
is,
guess
this is what I love about the, sorry, yeah, go ahead, John.
yeah, I love that Dave watches this because he can
And
just
it just makes me so happy. Like the Rask is such a nice community to always have people chiming in and being like, yeah, no, you're good. Yeah.
I mean, I think two or three of them are in Lyra.
They are, and that's
Like,
actually, we're taking a look.
right?
So we've already looked for the double in Lyra, which is Epsilon Lyra. And today we're looking at 2 more doubles in Lyra, but like every single corner of Lyra's constellation is a double anyway. So that does get a little confusing as well, I find. I did want to mention too, there are a couple different types of double stars. So double star, oh, I feel like there's a metaphor with yams and sweet potatoes here, but double stars are 2 stars that from our perspective here on Earth look close together. And then within that double star title, there's 2 separate types of double stars. There's optical double stars, which means that we're here on Earth, there's 1 star here, there's 1 star here. These 2 stars aren't actually close to each other, but from my perspective, they look right next door. They're not in the same system, they're just close to each other. So those are optical doubles, they're not true doubles. And then there's binaries or true doubles, which means that there's 2 stars orbiting each other.
Yeah, they're bound together by gravity. And a lot of the time you'll have, that gets a whole lot more complicated because a lot of the time the software might say it's a double, but there's no telescope that you can buy that will separate it. So if you're just going through Stellarium and like picking stars, oh, it says it's double, I'll go observe that. That's not a very good approach. Because in maybe even most of the cases, yeah, they're binaries, but they're not practical. Like they were discovered via spectroscopy where, they're using a scientific instrument to separate out the 2 stars and not a telescope.
Yeah, so it doesn't always work that way. So this is a good program in terms of giving you targets that are double stars, because then you're not just like going out and hunting for them. The ones that you're going to be looking for are going to be double stars. And they're going to be, what's the word that people use? Like you can split them or whatever. Anyway, you can split them by looking.
I split that double. And
there we go. Yeah.
Yeah.
Yeah. So let's take a look at some. I'll go back to sharing Stellarium.
And when you get that open, the story that I had is I didn't realize that sometimes a big telescope can be detrimental to seeing a double star, and using the double in Lyra as an example. I was using now as long as you know it's possible to split the double with the smaller scope, that the point is that the smaller scope is actually what you want to use. And the reason is, if you're using a larger telescope, it's more susceptible to the twinkling and the bouncing around that stars do. And that's because of the size of the air masses that are causing the disturbance in the air. So if you have air pockets that are like comparable to the size of your optics, they're going to mess it up. But if your optics are really small and the air mass is really big, then you're going to have less twinkle in your image. So I found it easier to split the double in the small scope like this than the big scope, because the big scope is taking light from chunks of different turbulent air masses. But the small scope, it's just taking light from like the same air mass. So your stars are more pinpointy in the smaller telescope.
Interesting.
Yeah. So cool. I thought that was, really, really fascinating. And to see it play out one night, quite obviously, switching, I'm like, oh yeah, I'm using this big scope. I should, because of the angular resolution formula, you should be like, yeah, this should easily separate these doubles. But that was superseded by the seeing conditions of the sky. So that was fascinating to me that, yeah, binocular, if it's visible in binoculars, you're right, it totally proves your point. Binoculars are better.
Just go with that. Yeah.
Yeah.
There's a question from Bob, which Blake and Dave Chapman have already answered, but I'm going to mention it out loud, which is, what about triple star systems? Can they exist? And yes.
Oh, yeah.
As like a general rule, binary stars include anywhere more than 2 stars. So 3 or 4 or 5 or whatever. And yes, then there's also things like the double double, which we saw as Epsilon Lyra, which I can show you here. Lyra, sorry. Maybe we'll move this. Anyway, yeah, that's this one here, which is 2 stars next to each other. And then each of those 2 stars is actually made up of 2 stars. I have the stars on too bright here, but each of these has 2. Let me change the star brightness. Each of them has 2, there we go. 2 stars within it.
Yeah, and I think
I don't know
even
if this
like
is the right setting.
Mizar and Alcor or something, I think that's like a 6-star system. And someone says, yeah, the three body problem makes it difficult for the orbits to be stable. But if you have 2 stars that are close together and a 3rd star orbiting at great distance, the 3rd star sort of treats the 2 stars orbiting close together as 1 star. So the orbital dynamics are simpler. Or you can have 2 doubles orbiting each other like that, stuff like that.
Okay. Orbital mechanics, not for me, but that's very cool.
Yeah.
There's actually a game
that is to be done on computer.
What's that, John?
Dave Chapman points out that is a work for a computer.
Yes, that is computer things. And also there's a game that you can play on your phone called Orbit, where you can try to get multiple bodies orbiting each other. It's just like a flick things around and like launch planets. And it's quite fun. It's also quite challenging to get multiple objects orbiting each other. So you can give that a try if you want to actually give it a shot. Okay. So we have Lyra, the constellation that is a lyre inside of the summer triangle. There's our summer triangle. We've already found this constellation before because we've already looked for the double-double. And then the 2 doubles that we're looking for, 2 of the 4 doubles we're looking for today are in Lyra. Each corner of this little like slanted parallelogram is a double. So you got to choose the right one and remember which one you're looking for. And I know it's kind of upside down now, and I still haven't figured out how to properly fix that in Stellarium so that it doesn't look upside down, but either way. All right, so the first double star that we're looking for is Zeta Lyrae. And it's the first star down from Vega, so it's this one right here. And that one also has a name, Nasaralwaki. That one's got the little double right there, which again, you should be able to see in binoculars, but it is pretty small, so you'll have to be pretty careful with that one. If like this is the whole binocular field, that's pretty darn close together.
Yeah.
And then the second double-double, which is Delta Lyrae, is much easier because, so this isn't a double-double, it's just double. Is much easier because the stars are quite far apart from each other. So
probably do that one even without a telescope, probably.
Yeah, you probably could. Yeah, if you have good eyesight.
Yeah.
So we have this one, which is Delta 2 Lyra, and then we have this one, which is Delta 1 Lyra. So that means Delta 1, I think, is brighter than Delta 2 or something along those lines.
5.5. That's tough at light pollution. But
yeah, you're right. Yeah, you're right. And it isn't brighter. This one's dimmer. But I think it's still possible. Yeah, I think with binoculars, it's possible. I think naked eye with light pollution would be tricky. But you could do it with binoculars. So those are the 2 doubles that you're looking for in Lyra this week. This one is cool because it is also 2 different colors. So you can see by the text, but also by looking at it, that this one is red and this one is blue. So that should be nice if you can see those 2 different colors. And then the other 2 doubles that we're looking for are in Draco, which is a big windy constellation that I always have trouble finding.
Yeah, the best way to view Draco, for me, is when it's high in the sky and then I lay down on a picnic table, and you really got to concentrate on tracing it out, and it requires fairly dark skies.
Yeah, so I'm not actually too worried about the constellation itself this week, even though I think it is one of the ones that you can identify for the program, maybe? I don't know. I didn't list it because I find it really hard to identify, and there's easier ones out there. But in this case, we don't really have to worry about the constellation because we can find our stars from the Little Dipper, which is easier. It's still hard in light polluted skies, but it's a little bit easier because it's so identifiable. So we already talked about this, but if you are looking for the Little Dipper, all you have to do is find the Big Dipper, which is real close to the horizon right now. and then use the 2 stars at the end of the Big Dipper's pot to find Polaris, which is the tip of the Little Dipper's tail, or the Little Bear's tail. So the 2 double stars we're looking for here are New Draconis and then 16 and 17 Draconis. To find them, this one's easy to start off because all you need to do is find the 2 stars at the Little Dipper's pot, and then draw a line from those down. And it's about a fist distance if you hold your fist at like full arm's length.
Yeah, and if you're in light polluted skies, those 2 stars might be the only ones you see.
They might be the only ones you see. Yeah. So it's 11 degrees, which is about that distance. And then if you zoom in, you'll be able to see. Oh, I'm gonna also switch off the star names.
Someone in the Q&A asked how far apart are binaries, and it really can range from, you know, a few AU, almost maybe even to a light year. I'm not sure, but that seems pretty far.
Yeah,
so
AU is
the distance between the Earth and the Sun.
Yeah.
And so most of the ones that we're looking at here are probably hundreds of AU in distance. And that means that it takes thousands of years for them to circle each other.
Yeah. And those, to be clear, that's just for the true double stars, like the binary stars.
Yeah.
Yeah.
That are actually gravitationally bound. So if they're not doing that, then they're not orbiting each other at all.
Yeah. The other thing to note as well is that I definitely had another thing before I started saying that sentence. Nope, it's gone.
Yeah. I think like Albireo, you know, if they're gravitationally bound, it's estimated at like 250,000 years or something for them to go around.
Yeah. What I was going to mention was that research has shown that at least half of the stars in our sky are actually double stars, that like they formed in double star systems. Up to 85% have 2 or more stars in their system. So double stars are actually generally more common than single star systems. So
yeah.
These
the
two
reason
in
why
this
we
case,
don't see them all as doubles is because they're only the distance away of like the Sun and Jupiter. So at the distance the stars are, they're all going to appear as 1 star. Like they have to be really, you know, billions and a few billion miles apart before from Earth we see them as 2 separate objects, even with telescope.
Yeah, so it's hard to tell sometimes.
Yeah.
These 2 are optical binaries, so they're not actually close to each other. This one, if you look at it, is 92 light years away, about, and this one is 412 light years away. So they are not gravitationally bound, they just look close together, and they're going to be very easy to see as well, because they are quite far apart. Looking at this as the field of view of binoculars, they are pretty far apart. I'll also take this opportunity to mention that first of all, I really like these targets for drawing because I don't have to be artistic really, I just have to get the relative distances right. And I find that they, when you're drawing these objects, it helps to, and you probably should, draw other stars that you see nearby. And then you can use that to help line up with what you're drawing from stellarium looks like, anything like that. It gives you a bit of an idea. So if I were using a telescope when we were closer zoomed in, I'd probably draw this little like pentagon thing and try to figure out which ones were the true binary or were the actual binary pair when drawing it out.
Yeah.
Okay, the next one is, I think, much harder to find, but it's cool. So I think that's why it was included in the program. And that's 1617 Draconis. Again, not using Draco because who would want to use the constellation that it's in to find it. So we had this little jump here, which is about a fist width distance. So we're looking at about the same distance again in more or less the same direction, except instead of straight across, we're actually going down a tiny bit. I'm pretty sure it's that one. This is the harder one. Nope, I'm wrong. It's closer. It's that one. So it's less distance. I find this really hard. This one's a struggle for me. Do you have tips, John?
No, but earlier, I forget it was this year or last year. I actually went out and did these ones. And
good for you.
But yeah,
they're tricky.
I forget if I wrote it down.
So this one, I mean, I guess the other alternative, and I've seen this used as well, is using the dragon's head to find the double star, because the brightest stars in the dragon's head point directly at it right here. I mean, and you can kind of see, like, you'll be able to find the dragon's head by going, let's see, there's the summer triangle. It's the like the mid-length side. So the side with Altair and Vega is pointing at the dragon's head. So you could try that option of looking for the two bright stars there and using them to point up or down towards the horizon to look for this star. I'm not sure.
And I used a telescope for these, and I used a Telrad to find them.
Those are like the circle things.
Yeah, and that made it fairly easy, because then again you're pointing at it before you go to the finder scope. So
right. Okay. So can you please describe what a Telrad is for people who don't know?
Do I have one? Oh well, this is sort of like one right here. You can turn it on. So this is a red dot finder. So the only difference between the red dot finder and the Telrad is that, if I put this up here.
Yeah.
Well, there's a little red dot, and it puts this red dot on the sky. And so a Telrad puts a bullseye shape on the sky. So that's the only difference. But so effectively you're placing this dot or this bullseye on the spot exactly where the telescope needs to point. And then you move to the telescope and see the object that you know is going to be there.
Yeah. So I would have just said finder scope, because all I have is, I mean, like, but I don't have, not even finder scope. It's red dot finder. That's all I have on my telescope.
Yeah. So with a finder scope, you know, where you're actually having the little telescope, that's more, that I find can be more challenging, because most of the time you've got an inverted image, and that might not match your telescope. Your telescope might, you know, be a 180 rotation or something. And the other challenge that you might have with that is, again, you're searching again. So you're using a finder scope, and then you're searching. The advantage of the finder scope, though, is it lets you then use it. You can see stars you can't see with the naked eye, because these don't magnify at all.
Right.
And so if you're using a finder scope, you've got magnification. You're seeing more stars. Okay. So it helps in the city, especially.
Okay.
So a lot of people, and so on my larger telescopes, I have both. So I have a Telrad and a finder scope, and then I'll alternate depending on the situation.
Okay, well.
Anyway.
That's fancy. For those of you just using binoculars, I mean, I would say the best way to do this is to maybe, once you've bounced over to this star, keep going till you see those two, maybe these two bright stars. And then if you keep going further in a straight line, you should see this come up in the bottom of the field of view. So maybe that's the way to go. But either way, once you zoom in, this one's kind of cool because it's, first of all, it's quite a tight double. So you should be able to see it split apart in binoculars, but even still, they're really close together. They are, I think, supposed to be about the same color, even though this shows one as being not quite the same color. And even cooler, both of these are also double stars as well.
Yeah, it shows them. So the color is the BV.
Right. Yeah. It's like so this is negative 0.6 and this one's negative 0.6. So it should be.
They're the same. Yeah.
Yeah.
Which is cool because it means they were probably really born out of the same gas.
Yeah, same class.
They're like literally like twins, and you know, big gas pile. Yeah. Great. Very cool.
And so then, but then if you click in the right spots, you do get 17, like there are two stars in 17 Draconis.
Are they the same distance? Are they?
They are, yeah, I believe so. Yeah. So hold on. Yep. 396.78 light years plus or minus 13.97 light years. Okay.
So they are probably gravitationally bound.
Well, they definitely are. And those are the two stars that some poet described as faint lilac and pale yellow. So theoretically, there is a slight difference in their color, bearing in mind that this is the color index is 0.04 for one and negative 0.06 for another. So you're getting like a 0.1 change.
You never know. So there are things that happen that in space that can change the color of stars. So you could have a big dust cloud that orbits them, and that dust cloud might go in front of the star and change the color. And that's one of the theories that if you look at like Ptolemy's book, which was the astronomy textbook from the year like 100 to 1400 or something.
Sure.
It's the Earth is
obviously everyone knows that.
Yeah, Earth is the center of the universe book.
That's okay. Anyway, there we go. That's what we needed.
Yeah. So in that book, Sirius, which is the brightest star in the sky, he describes it as red. And so there's a couple theories as to why there was, and one of the theories, I think one of the sillier theories that is actually the actual one they have that the scientific papers are on. They say it's because he looked at it when it was near the horizon. I'm like, that's silly. He's an astronomer. He would know not to look at it when it's near.
Yeah.
So, but one of the other theories, or not theories, hypothesis, because these aren't well tested, is that there's a cloud of dust that was, for maybe
In
100 years or
position.
so, was blocking Sirius and turning it red.
Okay.
Yeah. So my theory, which I actually tried to get a Chandra observation for, Chandra is an X-ray space telescope, is that so Sirius is a binary star. So you've got this big bright star, and then you've got a white dwarf star. And if you know anything about stellar evolution, white dwarf stars used to be red giant stars.
Right.
Yeah. So there used to be a giant red star where Sirius was, and but it can't dissipate over 2,000 years without us noticing a giant planetary nebula that would be in its place. So my theory was that there's a third star in the system that caused a tidal disruption event. That third star got close to the red giant and disrupted the outer layer of gas that made the star red. And then that star, went by and took that gas with it on its way. And now is gone. And so the reason we haven't detected that star today is because maybe that star was, a neutron star, I don't know, maybe even a black hole. But anyway, so the point is that stars could hypothetically change color. And maybe this person was describing it being that color when there was a gas cloud in front of it. I don't know.
Okay, I'm going to take this moment to remind folks that John does have an undergrad degree in astrophysics, but he has not done research on this. This is a speculation. This is not a fact.
No quotes.
Yeah. This is not a fact.
Not a fact.
This is a theory.
It's not even a theory. Not even a theory.
No, it's not. It's just like some vague
It's
rambling.
an untested hypothesis that I did write a paper on.
Untested hypothesis.
It was unpublished.
Sure. Yeah, that sounds good.
Yeah.
So yeah, it's not actually. So we do have a few minutes. One of the things before I talk about journalism and science, which I was about to mention at the beginning, my internet's not so great. Okay, we'll keep going. I wanted to just point out one of the last targets, which I forgot to mention, is the lunar phase, the waning crescent lunar phase, which I put on the list for this week on September 15th. This one is particularly tricky because you have to either get up at like 4 a.m, or wait a second. Yes, that's the only solution, isn't it? It's get up at 4 a.m. Or you can see it right before, because you can see it right before sunrise. Anyway, let's go find it. It's on the 15th. And it's it should be first thing in the morning, coming up in the east, right? That's right?
Yeah, right. Things rise in the east. So
well, then where's the moon?
Is that it by what's that hanging out by Leo there?
Is that the moon?
Do you want to search for moon?
Oh, you're right. That is the moon. Good spot. There it is. So you actually technically can see this one in the day, but it's real thin. So let's center it and go back to early morning. So yeah, you can see it in the morning. It's only at 6 a.m. So that's not even that bad. There we go. It's just really thin. So you got to get up early, or you got to try to see it during the day, as long as you don't look at the sun, which is really tricky.
Yeah, but if you go back a day, go to the 14th. Go to the 14th.
Oh, it's still visible the 14th. Okay.
Yeah.
And the 13th. So maybe 14th is better.
Then so if you go back, it'll get easier and easier. And then even if you go into the day there, it should be you should have a day like that one. And now fast forward to like 7 o'clock.
Yeah.
Go back to like the 13th.
Yeah, but technically I think you have to observe it on the 14th or 15th for it to be the right phase.
For it to be considered crescent?
Yeah.
Okay.
I think. So yeah, but you can still see it.
Yep.
There it is. It's thin, but if you're up early on the 14th or 15th in the morning, you should be able to see that little thin crescent. And I'm sure I've never seen a waning crescent before, because I am a bad astronomer. No, because I don't like getting up early.
I'm not.
I don't like getting up early or.
But I did. Yeah, I did get up at. I had to get up for one of the videos I've been making a YouTube video per day, for this homeschool astronomy challenge that I've been working on. And for one of them, I had to observe the space station, and I didn't have any like iPhone video of the space station, so I got up at 4:30 in the morning last week and put my iPhone in a tripod and filmed the space station going over the house. And so
nice.
Yeah.
There's a quick question from, oh boy, Karthika. Karthika, I'm not sure, sorry about if I'm getting the pronunciation wrong, which is off topic a little bit, but I think it's actually on topic, so that's why I'm answering it, which is, they missed the target Leo and can't find it anymore, so haven't sketched it. Is that a problem when it comes to getting the final certification? So the way the certification works is you can see approximately half of all the targets listed and still get your certification. So if you miss a constellation, it's all good. Just catch another one later on in the season. And we've gone over, or we will have gone over enough topics for you to miss like 2 or 3 or 4 per category, and still get your certification, especially with like I think we go over all of the lunar craters. That's not true, but we get close anyway. So you can miss a few and still get your certification. So no big deal. And if you get to the end of the program and find you don't have enough targets, there will still be targets to see in the winter. So you can always jump in and catch the winter ones. And we'll spend the last session going over some like brief overview of some of the winter targets, so that if you haven't finished it all up yet, you can jump into the winter observing. Winter is indeed coming and I'm not ready for it. But you see it's brightened up again outside.
They don't have the last 2 seasons on Crave.
They don't? Oh well.
No,
I have never watched it.
Yeah, so I've not seen the last 2. I don't know how Game of Thrones ends.
Oh no, I haven't seen any of it.
I don't even know if winter comes. Does winter come in Game of Thrones? I don't know.
Okay, Dad. I did want to just quickly mention something about science and journalism, because we wanted to talk, or at the beginning we were talking a little bit about science news, and then John discussed a theory for a great length of time. Not even a theory, an idea that doesn't have any evidence behind it. So I just wanted to show you guys just a screenshot that I took earlier from CTV that popped up in my news feed, which was peak 2020. Scientists say our galaxy is probably colliding with its closest neighbor, as if like this is news. The reason that we have always been on course to collide with the Andromeda galaxy, which is our largest neighbor galaxy,
but not in 2020.
Not in 2020. It's in 5 billion years. And along with that, so the likely thing that they're referencing here is the fact that recently scientists have found that there's this like big aura cloud of particles around galaxies, and it extends for a huge distance. Like we're talking Andromeda's cloud is like 2 million light years wide, which is huge because the galaxy is only 2.5 million light years away, which means that our aura of particles is also probably around that same size or a little bit smaller, which means that probably our 2 clouds of fluffy particles are already interacting, which is new science, but very poorly communicated in this, because it's not like it's sped up our collision with Andromeda. It's shown that we may already be like kind of touching a tiny bit.
I like Phil's comment, galactic distancing. And if you think about it, so I don't know. I mean, I did take a course on interstellar medium, but don't remember a whole lot. So it could just be what's called radiation pressure. So you have all these stars and they're pushing particles like a solar wind, but a galaxy wind. So to your point about galactic distancing, it could be like a permanent Milky Way sneeze, and it's going out toward Andromeda.
Beautiful.
With the COVID reference.
I like it.
Yeah.
Indeed. And I think when they say peak 2020, they mean like 2020 can't get any worse, and now we're colliding with our next door neighbor galaxy, except we've known this for years and it's not a surprise. So I think they're just looking for new things to stress about.
I mean, even if the galaxy was moving at the speed of light, it would still be 2 million years away. So
yeah, we still have a while. Yeah, and we can't move at the speed of light. So yes, everybody pack your bags and go who knows where, because there's not much we can do at this point.
You can't go anywhere.
Yeah, you're all stuck in isolation. So are we. So yeah, I just wanted to make that note. And I also wanted to point out too that there are some fantastic science journalists out there. Nicole Mortellaro edits our journal for us. There's a bunch of great people at the CBC, and I'm sure at CTV as well. And that it's not their fault for the headlines. The headlines are written by the editors, who often don't have science backgrounds. And so they go, ooh, flash, this will get people to click it. And it's not accurate. So yeah, no one's gonna be smashing into other galaxies anytime soon. Yeah, bring your towel. Yes, Ivan Semenik, there we go, thank you. Also fantastic. He's also a rascal. So yes, we have some fantastic journalists as a part of our organization who love space and do a great job at communicating space. And it's not their fault that the headlines are so sensationalist. So and Dan Falk, thank you, Blake, as well. I'm forgetting everybody's names. So yeah, just be cautious when you're reading headlines. Don't pack your bags and leave our galaxy yet. It's pretty cozy here.
And feel free to, tag us on Twitter and be like, hey, is this accurate? And we'll be like,
yes, yeah, you can do that.
I mean, I found
and
most
then one last
articles to be, especially on like major news sites, a lot of them are very misleading.
Yeah,
So
they can be. Yeah. And anyway, look, I'll save my discussion of science and how it's been communicated for another rant video later. But for now, I'm just going to answer one last question from Fabian, which is, does the program have to be completed in a single year? Is there a time limit once you start it? Absolutely not. We actually just had one of our youth members who is 10 finish the program, and she finished it in 6 years. So she started when she was 4, and she finished the program. Yeah, good for her, right? And she's got all these great sketches from when she was 4. Yeah, it's awesome. So you don't need to finish it in a year. We have it set up so that you can finish it in like the time period of this course over 20 weeks. Finish it in that you get enough targets to get the pin. Although some people do consider finishing it to be seeing everything. So if you want to see everything, that might take a little bit longer. You don't have to do it all in a year. You can do it in 2, you can do it in 3, you can do it in 20, just as long as you write everything down.
Yep.
Okay, I think
that's it for me.
That's it. And Blake says, John, if you want to get involved in the EAA, reach out to Blair Stunder, and I've got his contact information if you want it. He is the chair of the observing committee and the one who tells us whether or not we're saying the right things.
I know I'm always saying the wrong thing, so it's just like by default. So
just don't believe anything that comes out of John's mouth. He's great.
But fortunately, there's lots of people to correct us, so it's good.
Yes, we do, and we appreciate everyone like Blake and Katrina and all the folks in the comments and Dave Chapman who know their stuff. So it's we appreciate the support and the clarification, and I hope you all have a lovely time observing. I hope you get clearer skies than we've been having here anyway. And that you get to see that
bright light in the morning in the eastern sky. That's Venus. Just pointed out. It's not a UFO.
It's not a UFO.
Don't call us.
It's Venus.
That's Venus. Not on our list, but it's up there.
It is. You can go and see Venus, and you can see it, or the sun. Yes, that's true. And you can also, and don't forget to go out on Saturday for the Mars and Moon conjunction. Very exciting. Okay, we'll see you all in 2 weeks. Have a lovely afternoon, everybody. Take care. Bye.